Hey, Chem students, Mr. MB here. Sorry, somebody's moving behind me. We're gonna do some practice problems. So make sure you still have your guided notes out, and let's get to it. So we ended last video with sort of this crash course on metric prefix conversions, and also a review of dimensional analysis. Hopefully that was helpful to you. I know it's helpful for me just to see somebody else explaining something in any way, and what's also helpful to me are practice problems. So let's walk through these practice problems together, okay? So follow along with me. We're going to ask ourselves a question: how many grams are in 1.5 kilograms? So we always start with the thing we're converting from. 1.5 kilograms. It's going to set up our dimensional analysis. We're going to put on the bottom the thing we're trying to cancel out, and then on the top the thing we're converting to. So that's grams, okay? So I'd put a 1 for the larger thing, so we can look down here. This is just like a little snapshot of that larger table from earlier. But a kilogram, this one, is bigger than just a gram. This is our base. This is what those little lines are, the base unit, okay? So we're gonna put 1 kilogram, and the way we figure out how many grams are in a kilogram is we can do some work with these exponents, that power of 10 business. So we're gonna take 3 minus 0. That equals 3, so there are 10 to the third grams in a kilogram. Another way to write that, 10 to the third, we're just going to take our decimal point and move it over. Ooh, I'm sorry. I want to put my decimal point right here and move it over 3 spots, and it's a positive number, so we're going to move it 3 to the right. 1, 2, 3. Put in my zeros, so there are 1,000 grams in a kilogram, but I'll leave it as 10 to the third right now. So we'll then multiply straight across. 1.5 times 10 to the third. You can either write it like this: 1.5 times 10 to the third. Remember that our kilograms cancels because it's on the bottom and the top. Or you can do that work with the decimal point, and you can take this. Let me try to draw a little. Well, let me move part of this. Oop, excuse me. That's not what I wanted to do. I wanted to let me move just part of this, and it's not working. Okay, not going to be able to do that, unfortunately. Let's just zoom over to here. Here, we can cover up my face. You don't need to see it right now. 1.5 times 10 to the third. Another way to write that is you could take the 1.5, have a positive exponent, and we're going to move it over 1, 2, 3 spots. We'll add in the zeros, and we have 1,500 grams, and that is equal to 1.5 kilograms. Okay? Make sure you always box your answer at the end. I'll do it in yellow since I can. Okay? So that's the answer there. Let's come over here and do another one. We want to know how many liters are in 1.25 milliliters. So start with the 125 milliliters. I think I read that wrong for you. It's 125 milliliters. Then we want to cancel out the milliliters. So we'll put it on the bottom, and we want to go to liters. We'll put that on the top. Remember, we do a 1 for the larger thing. 1 liter is going to be bigger than a milliliter. We can look down here and remind ourselves that these are going to start to become negative exponents. So they're getting smaller. It's going to the left on our number line. So we'll subtract the exponents. We had 0 minus -3 equals 3. 2 negatives in a row become a positive. So that 3 will be what we put here, 10 to the third milliliters in 1 liter. We know that the 10 to the third, another way we could write that is, try to write it in here small for you, 10, or 1,000 rather. So there's a couple options there for you. So we're gonna take 125 times 1, and we're gonna divide it technically by the 1,000 because the 1,000's on the bottom. So let's start by just canceling out the milliliters. Here, I'll scoot over so you have some more space. So we're gonna end up with something that looks like this, 125 divided by the 1,000 liters. And we can obviously put that in our calculator and solve that, or we can, actually might be the easiest way for you. Another thing, this whole power is a 10 that kind of makes things a little bit easier is you don't necessarily, if you're just converting within one unit like this, you can just kind of move that decimal point. So if we look back here, we saw that 1 liter is 10 to the 0, centimeter, or milliliter rather, is 10 to the negative third, and if it's to the negative, you're gonna move the decimal to the left. So another thing I could have done is I could have said, hey, 125 milliliters, my decimal point's right here, I'm gonna move it 1, 2, 3 to the left, because there's a negative exponent there, and that would have given me the same answer, 0.125 liters. Those are rather some practice problems for you. Hopefully this is somewhat helpful, not more confusing. You have practice problems to work with on your own, and feel free to work on those as a group as well. It's a good way to practice together. You got it.